Hello, everybody. Thanks for attending my talk today. As you can see, it's going to be on metamorphic transformation with enterprise-wide artificial intelligence. A little bit about me first, very quickly. Betsy and I, my wife, have been in New Mexico for 11 years now. We came from the Bay Area and had some old relationships and overlapping science here, especially the Santa Fe Institute. So I spent several years maturing KYield while I was a frequent guest up there. And even though we didn't work on KYield specifically, it was beneficial to sit in rooms, small rooms like this, and explore emerging research in a lot of overlapping areas. So a little bit about this. This is one of the ways we communicate the system. It's difficult to do visually, but our system is enterprise-wide. It's universal, so it applies to any type of organization or network. We are inspired by biology in our work, so this is a form of biomimicry, but we're not explicit like a lot of companies are. In other words, we're not trying to exactly copy what happens in biology, especially the human brain. And one of the reasons is pragmatic. Human brains, we have the most powerful supercomputer still on our shoulders. So to me, it makes no sense at all to not tap into that, whether you're accelerating R&D or for any other purpose. So all of our focus, for the most part, is on enhancing human workflow, accelerating R&D. And on the left side, so we have a modular system. We have individual modules, group, customers, et cetera. And then on the front is sort of the spearhead is adaptation. So you'll see that's a common theme in our work, is continuously adapting. And then on the left side here, we have the functions that are embedded in the core system. It's not the only thing that we do, but this is the older system that is core functions that are embedded. And again, we're using, actually my wife and I took all those pictures. We're not copying these functionalities exactly. There is some good organic R&D going on now that are attempting to replicate what goes on in biological systems. But in our case, we're just attempting to achieve a similar outcome. And so with that, we'll move on here. I wanted to start with the key issues that I'm confronted with in dealing with organizations in the enterprise, because this is a very important topic. It deals with everything from national security to competitiveness of organizations, economic security for regions, et cetera. And so on the top, we have broad consensus that this is the most important technology of our era. Whether or not it's the most important in history or not depends on what we do with it, of course. It certainly has the potential in my view. But how the AI systems are designed and how we adopt them is a very important issue. So a good example of the adoption situation at the national security level that we frequently discuss with leaders in national security is between China and the United States. China is of course a totalitarian communist regime, and so it doesn't need to worry about popularity or any of the other things. Now, that's something that we wouldn't do in the United States. It does create problems for us in terms of technology and our ability to defend and keep up. So they are ahead in certain areas. So how we adopt is very important. Now, on number 3, we discuss here, only 21% of organizations so far have adopted AI systems across multiple units. This is really important when you get down to the state level, city level, organizational level in terms of competitiveness. And we'll get into that in the next couple of slides of why that's so important. This was actually a survey by McKinsey that was done last year. It was no surprise to those of us in the trenches working on this, because I confront this all the time with leading organizations. However, even in that 21%, let's say it's 25% this year, that is, generally speaking, only across 1 or 2 business units. So we're not talking about system-wide, unified systems working together and accelerating R&D, productivity, et cetera, to be competitive. And so number 4 is most organizations are still experimenting with small projects. This is how most consulting firms advise clients. And typically that is the way you want to do it in software. You start small, you learn as you go, and then you morph into larger systems. Now with unified AI systems, there's a problem with that. They need to be very well engineered. So our background in this goes back 23 years. I conceived KYield 23 years ago. And so we have governance, security, we've thought through productivity, a lot of different factors that go into these systems. So if you're just starting small, and let's say a small machine learning project, that can be very powerful. You can be working on a new drug, for example, and that's occurring now finally in scale. But it's not going to do certain things that are physically required for you to have a unified system. So most organizations, most of the organizational value, I guess that last number 5 was cut off a little bit, is you need a unified system. So for example, prevention of systemic crises. We did a HUMCAT program a couple of years ago. There was a runner-up here in New Mexico for the Innovation New Mexico. And HUMCAT stands for Prevention of Human-Caused Crises. So 9/11, BP oil spill, the Wells Fargo sales scandal, the lots of different multi-billion-dollar events that impact society. And you can't, or cybersecurity. So when you have a system like this installed, only then can you deal with, for example, human behavior problems in cybersecurity. Most of the problems in cybersecurity are still caused by human behavior. And you physically can't deal with that unless you can obviously be installed where that human behavior is taking place. There are some other ways to address it. So this is a productivity chart that I did for chief decision makers last year. And this is based on 3 different organizations that adopt AI systems in different ways. And it's quite interesting. The base, financial base is $100 million, so they're treated all the same. And then they adopt it in different ways over a 10-year period. And so they reinvest their money on a continuous basis. So this is compounded, but the actuals show the outcome at the end of the 10 years. So what we have here on the bottom, we have the turquoise, and the turquoise is actually 8% below the base rate. So the base rate, the red line, is an organization that is just staying neutral. So they have inflation, that's inflation target rate. So 2% a year over a 10-year period, and they end up with something like $186 million. They start off with $100 million. So this effectively shows the wealth gap, right? And so that's what this is. What happens with adoption of technology and the different ways societies and organizations, it can be nations, it can be states, cities, corporations, it doesn't matter. And really what this is a knowledge yield curve. And is driven by AI systems, enhanced by AI systems, and then you have the financial outcomes that determines the wealth of your society. And this really caught a lot of surprise. This is quite, CEOs of major organizations and leaders in large organizations found this to be pretty important and powerful. So the top line, the blue line, shows an organization that is just acting prudently. So in other words, they're not a leader in AI systems, they're not a high-risk organization, anything like that. We're not talking about Silicon Valley, high-risk VC or any of that. This is just a regular organization that's adopting, that's doing pretty well across the enterprise. And at the end of 10 years, they end up with something like $416 million. Now, what's really interesting about this is that I'm not even showing the leaders. If we showed the leaders, it would be nearly vertical. That's powerful. But they're also real. This shows the old network from about 20 years ago. This is a semantic neural network. In our system, that was the first thing we had to get right, was to structure the data in a very specific way so that it's efficient, that it works well, so that you can embed security, you can have governance across the organization. And so this has been around a long time, it's nothing new. How we do it is a little bit different. but I wanted to show you that because it's very important. In the center is the CKO engine, and that's a semi-automated bot, essentially, for the network, and that is the chief knowledge officer. And then the humans in the organizations with high security clearance manage the CKO engine in just a natural language interface. So it's very simple to use, but that manages governance, and then every individual has their own. Now, the important thing here is with machine learning, we can do most of what we do because of the semantic neural network. In other words, the structured data allows us to use machine learning rather than deep learning. Why is this important? We'll get into that in a second, but one reason it is it's transparent. So any individual can click on their module anytime to see what type of algorithms are being used and why. And for almost every purpose, it's to help the individual. So whether you're a patient, whether you're a knowledge worker, no matter what you're doing, this is tailored to your interests. And so you can see the transparency, which is very important. Now here, most people have seen this now because it's because of the hype and everything since 2012 on the web. This is a deep neural network and deep learning algorithms that we use. We do use this for specific functionality that you can't do otherwise. So that's my criteria basically in the system is if there's no other way to do something and deep learning does a better job, then that's what we use. And so there's lots of different algorithms that you can use, but more recently I've been interested in evolutionary algorithms to achieve very interesting results in things like autonomous cybersecurity, which is another reason why unified systems, it allows you to do some neat things with autonomous cybersecurity, because no human is fast enough to react to the automated bots that are coming in to try and break into our networks. It's just too powerful, too quick. This is an older diagram on the industrial, and so at the bottom there he shows the productivity, security, privacy, prevention, some of the things that we focus on. So ethics is very important to us, always has been, it's built into the system from the beginning. This is an example of fairly primitive now, but it's tailored to me. I wanted to show what an individual module looks like. This is just one way you can manifest this type of system in a modular system. This is your individual. So at the top we have the prevention. Below the navigation bar you have the prevention functions where it will automatically alert the right people in the organization. So if you're a supervisor of a hospital, let's say, and you have a very important, let's say a power outage or something that needs immediate attention, this will show up on your phone, will give you a beep, an alert, and then it shows who are the other team members that have been alerted. It'll show you the type of event, a code. So it tells you, this is code red, this is code 2, whatever code that the organization wants to use. And then it has some actions. So it shows links to the type of actions that you need to take, and then it confirms those actions. So very briefly, 9/11 with the FBI. We had a Phoenix memo that was sitting in their system for weeks that nobody did anything with. And it was very explicitly warned against even the names of some of the people on those airplanes. Now, if that had been acted on during those weeks, we could have prevented 9/11. So that's how important this is, potentially. And then there's some productivity charts about myself, some of my own interests in reading. Down here on the 4th row, we have some projects and color-coded charts. It allows me to see how my projects are doing and the teams and different things. And then I have some feeds, artificial intelligence and economics feed that I'm interested in. Those are basically from publications, journals, that sort of thing. So I just have it in one place. On the right-hand side, underneath Warren Buffett, that's a really important thing I want to highlight. That's a data tuner. And so that's in the original system, part of the patented system. So that allows you to very easily control the quality and quantity of data that you're consuming. So if you have a really important deadline coming up or something and you really want to ratchet back on the noise, you can increase the quality of the data that feeds. Now you can't, in this system, you can't do anything about the alerts because that's too important. That's a sort of an organizational governance issue. But for the most part, you can control that completely on the volume. And then down at the bottom, it's just some integrated communication, so you can, your partners, your customers, your team members, staff, you can very quickly communicate to the extent that social networking and others that will allow you to integrate. And then on the bottom are just some quick administration functions. So if you want to do a quick way to do something with your individual module. So that shows you what an individual module looks like. I wanted to share patient management. This is actually from a paper I wrote in 2010 that is, the title is Diabetes in the American Healthcare System. That actually was downloaded by several million people. It was surprising that it became so viral. And at the time, it was a futuristic paper. So there were several things in it, and it showed how you had to integrate with our very complex regulated environment in the United States. How would a system like this work with our medical system? Really important because, as most people are well aware, we have a systemic problem in our healthcare system. The costs are about twice as high as the next country, and the quality, we're not rating very well on quality. So we do need some, if you have a systemic problem, it requires systemic solutions. A lot of that is regulatory, but it's also these type of systems. So I wanted to share that. You can search for that if you want to read it. Most of the things that were futuristic then are no longer futuristic. Now this is the outcome. This is the desired outcome for this type of system, is a KYield, and that's a continuously adaptive learning organization. So if we think back about that productivity chart that I showed, in the top blue line of the company is probably only achieving, say, a 60% KYield. There's no one, to my awareness, there's no organization in the world that's achieving a real continuously learning organization. But what really matters is every organization is at some scale. So it may range from 3 or 4% on the bottom up to maybe 70, maybe 80%. Now the really important thing to understand here is that that wealth gap that we showed between big tech, some of the newer companies that are like ours that were native from scratch, they are much closer than anyone else in achieving this. So they're much more productive. You see that in the corporations. You can see it in the how much revenue per employee. There's a lot of different metrics that can show that. But here we have automated regulatory. So this was actually for one of the tier 1 banks in 2015 that I was talking to, and I wanted to demonstrate what they need to look like. Now they are having some very serious problems. So what we're trying to do are a couple of things. One is we're trying to reduce systemic risk. So if all the banks were using this and it was automatically reported, we would be able to do not just our system, but we use interoperable industry standards, so on the data. So this would enable the regulators to do a much better job of preventing the next financial crisis, for example. And our patented system is actually just up on the upper left under AI augmentation. The rest is a combination of open source and trade secrets and integrated with proprietary systems. But again, to my knowledge, no one in the world is doing this yet fully across the whole organization. So I wanted to share the Genesis project. This is kind of funny in a way. A couple of years ago, I just happened to come across the Star Trek episode on the web, and then I realized what the inspiration was on this because I did this earlier. There is a Genesis device in a Star Trek episode from 1982, and I remembered seeing it. And it's a biological device that is somewhat like a bomb. It's a little scary, but its purpose is to immediately change a dead planet into something that that humans can live on. Now that one failed. It was a very radical experiment that they needed in Star Trek. Fortunately, ours is much easier. But this is intended to really get organizations up and going right away. So the very morning that you install your individual module, you can hit the ground running. And that's one of the big holdbacks really for this whole industry, especially in the United States versus some country like China that just orders it done and it gets installed. We really need to make this as simple as possible for people to get up and running quickly. So that is what the Genesis project is for. Now this is not completed yet. It's a very resource intensive effort to do that. So I wanted to also share, and I had in the bio, a new invention that is, it can be operated independently, or it can be operated with our KYield OS. And this is a synthetic genius machine and knowledge creation system. I just applied for this patent about 3 weeks ago, been working on it for many years. And it's quite interesting because what this does is we take real work from real geniuses going back hundreds of years. In fact, the example that I use in the patent itself is Leonardo da Vinci. So we take a lot of his published work is available, and we build models around his work. So this is primarily to accelerate R&D, to help people, or whatever problem that you're working on. You know, how would an Einstein deal with something like this? If you're dealing with a difficult project, how would Leonardo, how would a great artist, or a contemporary, how would a great surgeon attack this specific tumor in this specific brain? So that's what this is for. And in the case of Leonardo, the person that queried it probably got a response that they didn't expect. They expected Leonardo to know everything. Well, Leonardo doesn't know everything. In fact, he left very good notes from 1490. He does a lot like all of us do. Before a project, he would talk to experts. So he would talk to mathematicians, he would talk to engineers, and before he would engage in a project. And then his specialty as a true genius and amazing vision was to connect those dots and somehow magically come up with an invention for a helicopter in 1490 or 1500 or whatever year it was. Now, this is very practical for addressing challenges today because when you get into the disciplines, we have discipline models and then we can cross disciplines. What we do is we extract genius components or genius features into small units, and then we have a proprietary language. So we convert that to a symbol. So we have symbolic representation of these genius components, and then we mix and match them for whatever need you have. So a famous physicist, psychiatrist, I'm having a down day, maybe I need a famous psychiatrist to bounce an idea off them why I'm so depressed. My dog died, you know, or something. But so there's a lot of pragmatic uses for this, engineering and contemporaries. Now in an organization or across organizations. Now we also have what kind of interesting is serendipity model that also uses real life events. So there's lots of different famous inventions, things like the Post-it notes is a very famous one where they invented this glue 3M, but they didn't have a use for it. So they had solution, but they didn't have a, you know, what are we going to do with this thing? Well, that's the type of thing that supercomputers and machine learning are really, really good at, is connecting these dots. So you come up with an idea, you come up with something, you may need help from experts to be able to connect those dots. And again, the idea is to accelerate R&D so that we can get much, much better, much, much quicker at coming up with disease cures and that sort of thing. Or, you know, space travel, whatever it is. There is also on the one other thing, as the scale grows with the Genius Machine into, when you're talking about these little genius features, I mean, it really just goes off the chart on how big the system can get. It becomes a really perfect match for quantum computing. So we're spending a lot of time in matching this with quantum systems. And with that ends my talk, and hopefully I have some good questions out there. We have a microphone too that we'll pass around. Any questions? Great.
So what do you see as the biggest impediment to adopting an AI project? So just somebody in general who just wants to, you know, just get started on that.
Well, the good news is that the little projects, and thanks for that, by the way, the little projects, we're actually doing pretty good now. A lot of organizations are starting small in these little projects, machine learning. And there's just an explosion of learning. So for example, a few years ago, the top academic conference in the world, and there was only a couple of them, you'd have fewer than 1,000 people would show up, and they all knew each other. So every single person in the world working on this were known. And then it just exploded. So now there's a whole bunch of conferences. There's thousands of people. There's PhD programs all over the country. There's MA programs. But there's also a lot of free stuff. So you can do, if you're a pretty good learner, you can actually learn machine learning. In fact, the vast majority have, and get up and running and actually make a darn good living right now because there's a real talent war. So you can get started on these little projects. Large organizations have the data. It's a bit of a problem for smaller organizations because they just don't have as much data. But that's happening in, I'm going to say 40–50% of the organizations today are doing small projects. The real barrier comes in large system like ours where you achieve the greatest results. And you can't close that gap between a small project into a unified system. So we're doing it backwards. In other words, what you need to do is install a system and have the infrastructure in place and then run your projects on top of it, because then the ML projects are much easier to do, much quicker, much less expensive. So that's one way to look at that question. Another way that is occurring is that the leaders in AI systems, the big tech and some of the larger market leaders. For example, I won't name any names, but we just engaged with one of the leading banks in the world for several months. And because it is system-wide, we deal typically with the CEO and the senior team. And they look this over very, very closely. They have one of the biggest budgets in the world. And they also have, they're considered high risk for systemic risk by regulators, so there's a lot of attention in a company like that. And in their case, they decided to build it all scratch internally rather than work with us or anyone else. So they're not going to work with any tech company. They're going to build it all internally from scratch. Well, here's the problem with that. Not only is it bad for us and by extension New Mexico, because we're based here, that one project alone would have catapulted our company into one of the market leaders in the world in this. We have one of the few AI systems. We've been working at it for 23 years, so we have a lot of research, a lot of trade secrets, and they're going to, our estimation was they have about a 40% redundancy. So they're going to be wasting about 40% of their budget by doing it all internally. But beyond that, what's more important, what bothers me the most, they have the money. They can burn the money if they want. I mean, they really do. Very profitable company. And they have a lot of good people. But the really sad part of that is that we need those leading organizations to support this generational change for the United States. That's one of the reasons we're behind. If these large organizations are not supporting these new companies as they have in generations past, it's very difficult for you to be competitive with the rest of the world, because Canada is doing a very good job, Australia. It's not just China. In fact, the EU just came out with a recent paper, and one of the suggestions for the EU is to spend $100 billion in AI to accelerate for those very reasons. Good question, thanks.
So obviously, if you integrate AI into business, it's gonna pretty much, depending on how you use it, it may just kind of wipe out a whole set of employees.
Yeah.
Have you seen organizations prepared for this or understand what they're getting into, and how would you suggest they would prepare for that?
Well, the most common question is fear of AI, and it's justified in some sense and not in others. In fact, I wrote an article several years ago that was featured at Wired magazine, and you can look up my name and Wired, and you'll see it. And we were actually at SFI with some of the leading minds talking about this issue then and looking at it. In our case, we don't go after specifically to replace employees at all. In fact, we're doing just the opposite. We're boosting the employees to make them more competitive. So in essence, when you do that, they should be worth more. So if you look at that, think back at that chart, the leaders in the blue line, those are companies, they're making so much more money than the other companies. They're able to pay, and they're paying their employees multiples of what other companies are. So that's one way to look at it, is just, sort of the survival mode. I compare AI to electricity since the 1990s as one way to get your head around this. It's not a perfect comparison, but it helps to understand the revolution that took place when we harnessed electricity. It was so radical, a lot of people were very afraid of it at the time. Same thing happened with combustion engines. But as the electricity, the products grew, you had appliances, you had standards that had to be built so that they were interoperable, and you had massive GDP growth and productivity growth, and also wages and employment all went way up. So most of the fear represents the unknown. It doesn't represent necessarily the outcomes, frankly, because none of us know yet. I'm confident it's going to surprise. So far, we're actually adding jobs significantly more than we're replacing. One of the problems is that people are overconfident in the ability of AI systems to replace humans, and they're underestimating just how much. Remember back on the most powerful supercomputer in the world today in neural systems is reported to be Spinnaker. And Spinnaker only achieves 1% of the human brain in terms of its efficiency. Now there's a new system that was just announced that's going to be over at Lawrence Livermore and built by our friends at Cray, and that's supposed to have the brute power of a human brain. Most expensive, most powerful supercomputer won't be available for several years just to meet the brute power. However, you still have all kinds of qualitative issues, I should say, that humans are better at. So we have, I think the best way to look at this is that humans are much better than computers at some things. And there are some things that computers are much better. For example, my memory is really not very good. And a computer is almost perfect. So I rely heavily on it. However, that said, there are specific jobs. For example, if we do adopt autonomous driving for trucks, I mean, that's an example of if that becomes widespread and scaled, then yeah, those truck drivers are going to be at risk. But for the most part, this is about adapting in your own. Really what's happening is little pieces of each job are being automated because those are the ones that financially you can do. And we're really nowhere near decades and decades away of being able to replicate most jobs. And that fear comes from, I always compare it to, well, when's the last time you tried to repair plumbing in your house? Do you think a robot's going to be able to do, and when you really look at most of these jobs, it's going to be a long time, if ever, from an economic standpoint. These are not cheap. These systems are very expensive. So it's a very common question. I think it's mostly has to do with fear. The more I learn about this, the less I'm worried about those jobs. I'm more worried about the United States falling behind, New Mexico falling behind, the companies that I'm dealing with falling behind. And that's really the big risk, is allow that fear to allow you to make bad decisions and fall behind. So good question, thanks. More questions? Yeah, thanks.
So when you go into a new organization, how ready is their data to plug into the system?
Great question, and that's a really that's why the semantic neural network, as I showed, the reason why from very early on we knew that organizations were not. I used to be very involved in that from back in the 90s and had a lot of colleagues, and we knew that most organizations were not doing a very good job on their data. And if your data is not being structured right and the intel is not very good, then the old thing of garbage in, garbage out, that's what's going to happen. And with AI systems, it accelerates that, make lots of mistakes. So we had to get that data right. Now, this is not for the whole organization. Still have to integrate stuff. But in our system, to get the accuracy we needed, to get the governance that we needed, we had to design it up front just to avoid the problems in the turf battles and the regulatory issues and the interoperability. I mean, those that are not involved in the data world, I mean, it's just unbelievable what goes on. And then there's data standards in the different industries. And even today, we have standards, but not everybody uses them. So you have organizations not interoperable. You can't possibly prevent systemic crises if the organizations are not even talking to each other well, if you're a regulator. So that's why we do it, and it's automated and semi-automated all with one system, because We just, otherwise you spend, for example, in ERP, 2-3 years ago, I think it was Forrester did a study, and they found that something like 9 out of every $10 of an ERP installation was in services. In other words, data wrangling of some sort. So good question, and that's why we do it this way. I don't trust them. Can't.
Regarding China, do you think they have a leg up because of the way they're governing?
Yeah.
Essentially, command being sense, whereas we have to go through privacy regulations. It's much harder for
Yeah.
them to get access.
Well, that's probably the biggest question that's been on the mind of national security folks for the past couple of years. There's been some pretty good work since with a fair amount of good information. I would frame it this way. China's advancement is somewhat exaggerated, and the type of thing, scale is not the most important issue in AI systems. It is the most important in machine learning. So to differentiate between the two, when I was talking about our latest invention in the symbolic language and some of the new encryption, some of the things, for example, simulation is already being used by top labs an awful lot in AI systems. And so there it becomes sort of a purely mathematical thing, and the US is way in advance of that. Some of the Europeans are way in advance of that. So even though that China it has the largest scary national system that is, essentially watching everything everybody does, and it's basically a large police state, that does give them certain advantages in machine learning, and they did learn very rapidly. Frankly, I'm much more concerned with what we don't know about what they're doing. Just like in the US and in other countries, they have secret work going on. I can tell you that I became especially concerned. In fact, I did a personal letter campaign to all the leaders in the United States, warning them early last year of the national security problem. We could see bad guys from China on our own website, and the way they were studying our material, it was obvious that somebody was spending a heck of a lot of money trying to reverse engineer our system, and more than likely for the PLA, for the military, not for, to discover new drugs. And so I became very concerned, combined with that the US is very, very slow in these enterprise-wide systems, at least that we know about. There may be some classified systems that nobody's talking about, but from my friends that are exposed to it say, probably not. So I'm concerned with the enterprise-wide, the network-wide systems. I'm not so concerned about the science yet. Now, with that caveat, here's the problem. If we don't adopt these important systems that can accelerate R&D, then we have a serious problem, because the compounding effect is so rapid with these systems, and the learning is so rapid. Even if it's not purely computational, even if it's enhanced scientists in their work or engineers, you can rapidly fall behind. So then it's a problem. So I'm cautiously optimistic, but yeah, that's the one thing that keeps me up every night, because I know what the outcomes will be, whether it's military, whether it's economic. Either way, we need to get on with this very rapidly. The problem is large organizations like the DoD, we can get them excited to move, and now they have a sense of urgency, but getting them to move in the right direction is an entirely different matter. And that's where we seem to be suffering. So thanks, good question. Any more questions? Oh, right next to you over here.
Use the microphone.
In comparison to China, is there a Western entity that has a single entity that has a similar level of development, access to a data set?
Google. Google has, and there are some of our scientific research institutes have a lot of data, especially saw a really good, immediately came to mind. I forget I remember the person, the director of the lab, but I forget who it was. They did a presentation at SFI a few years ago, and they were just collecting just unbelievable amount of data sets in space R&D. So that would be one example. Google collects, as far as I know, the most data on sort of our real world environment, and the NSA. But the NSA is not necessarily relevant to all these issues because they're after just sort of the metadata and certain things. So they collect an enormous amount. But even in even in the large organizations, it's just phenomenal how much. But the labs have a lot of data. But this kind of goes back to the simulated environment that I was talking about. Is that when you combine the real world with simulation, you can then produce essentially unlimited amount of data. You're only held back by your compute power, your storage, and that sort of thing. And so that's where the science part of it in the U.S. and our lead becomes really important, and some in the EU, the top labs. So at this point, I'm not so worried about the science as I am. Right now, I'm actually more concerned with military applications. For example, you could, China is the biggest manufacturing power in the world by far. They could produce 1 billion drones, and they don't even need to be necessarily that smart, right? If you really wanted to be evil and kill all the Americans, not that they would, hopefully, but if you wanted to do that, we don't have anything, to my knowledge, that could do anything about it. So it's things like that I'm worried about. And then the other thing is the economics. So economic security right now is my biggest fear, certain military applications. But fortunately, I mean, the world has woken up. We seem to be, what is it, Churchill, the old saying is that America eventually does the right thing after we try everything else. I think that kind of captures it pretty well. So thanks. So one over here.
You discussed the slow adoption rate, and it goes back to you did the financing and then explaining. You used the analogy on power, electricity back when it was scary and people didn't understand it.
Yeah.
So it goes back to people not knowing what they're getting. And I think we're all in IT. We understand trying to explain what is necessary to people that don't actually understand what we're trying to explain to them. Yeah. So how do you start that conversation and presenting the pain points and what it can solve?
Well, I'm probably the right guy to be talking to. I've spent, oh my goodness, the last 20 years, I've spent most of my life doing that. It's tough, and I used to think I was a pretty good communicator, but that's thrown out the window now. The bottom line is easier to show them. And that's why in our unified system, we're trying to get this done so that especially in our software world now, it's much easier to do than it is to explain. It just takes a lot of resources to do it. That's the easiest way to do this when we're talking about the masses. Now, when we're talking about chief decision makers in organizations, that's a little bit different. We've pretty much won the scientific argument. It was kind of like we were talking about in the previous question about the DoD. We've won the argument. You can see that. They've got a sense of urgency. They're spending money on it. The problem is getting them to execute in the right direction. And even, nothing to do with our particular business. But for example, I've been actively, I was very supportive of AWS, of the CIA adopting AWS when they did it, for example, and it was across the whole organization. But since we run an operating system on those types of infrastructures, it can be run on any cloud, any configuration. I'm very concerned about the systemic risk and some of the other factors. So I'm no longer supportive of the DoD, the Homeland Security. We've got most of our financial system is on AWS. And then we had the Capital One event that comes up where you have one bad actor that worked at Amazon, an engineer, that came out and hacked Capital One. They could potentially bring the whole system down. So this is the type of thing that I'm talking about, moving in the right direction. Then they get so urgent about it, and we got to get this right away, and AWS is the only one that can handle the scale. Well, I compare it to running off the cliff in the wrong direction. So having a sense of urgency is needed. We got to worry about this stuff, but we don't want to act like lemmings running off the cliff. That would be the worst possible scenario. So a lot of my time is spent educating senior executives. The really difficult part is to get them to decide to work with a small company, in our case, that doesn't have the billions of dollars behind them, and it's still saying about Big Blue. Nobody ever got fired hiring Big Blue. Well, today in cloud infrastructure, that's AWS and maybe Azure, whatever, and there's very few companies. None of those companies have what we have. So that's kind of the problem. So each situation, I'll tell you one of the big, in combination with the other question about fear of job replacement, combine those two questions, that's where the problem is. People are afraid of getting replaced inside organizations, including IT folks, very senior IT folks in some cases, which is not rational at all, in my view. And then you combine that with the turf protection in the organization and who controls the funding. So we get into this problem where you can demonstrate, look, we can prevent the next BP oil spill with systems like this, and that was nearly fatal for BP. It's $60 billion. They didn't know if they were going to survive or not. And believe it or not, in the case of BP, I had relationships with the CEO. We had common relationships, pretty easy for me to get in. But the individual that I was talking to at BP who was in charge during that event and afterwards wouldn't spend $1 million for a simulated event to demonstrate that you could save $60 billion. So that gives you an idea of the accountability and the fear factor. He was shaking in his boots about the accountability. Well, you can't have a system that works well if it's not accountable, if you don't have accountability built into it. So it is an ongoing challenge, but I'm convinced the best way to do it is to show them. Just have it done, turnkey, boom, you're up and running. That's what that Genesis was about, get it going. And we can do it, it's technically viable, but it does require resources. So, okay. Anybody else? Thanks. All right.